What if you could solve one of the oldest, most fundamental problems humanity has ever faced? The search for clean water, with our planet's most abundant resource. Well, today, we're going to look at an incredible innovation that does exactly that, turning pure sunlight into safe, drinkable water. So, how on earth does that actually work? Let's dive in. First things first, to really get a handle on the solution, you have to understand the problem. And at the heart of the global water crisis is this fundamental challenge. It's kind of like a classic chicken and egg scenario that traps millions and millions of people. And look, this is not some abstract, far-off problem. This picture shows the daily reality for communities all over the world. The research from the National University of Lesotho really drives this home. Communal wells, boreholes, they're often contaminated. And that leads to a huge amount of waterborne diseases, especially hitting kids the hardest. The scale of this is it's staggering. We're talking about nearly 800 million people, according to the World Health Organization. To put that in perspective, that's more than double the entire population of the United States facing a risk every single day just to get the water they need to live. And that brings us to this core idea, what's known as the water-energy nexus. Think of it like a feedback loop. You need a ton of energy to get water, to pump it, treat it, and move it around. But at the exact same time, you need a ton of water to produce energy, like for cooling power plants. The two are just completely locked together. So what happens when you're missing one side of that equation? Well, in a place like rural Lesotho, where only about 10% of people are even on the grid, this nexus becomes a massive barrier. Without reliable energy, you just can't run a conventional water treatment plant. It's impossible, and communities are left stuck with unsafe water. Okay, but what about the big gun technologies? The ones that can make fresh water anywhere, even from the ocean. Let's take a look at one of the most powerful solutions out there and uncover its biggest and most surprising hidden cost. Desalination. I mean, it's a total game changer, right? It takes salty seawater and makes it perfectly drinkable. But it's always had this reputation for being ridiculously expensive. So you have to ask yourself, where is that cost really coming from? Is it the price tag for building the plant itself? Or is it something else? And this is so interesting because it completely flips the script on what you'd expect. The initial investment, the money to actually build the plant, that's only about a quarter of the total cost over its entire lifespan. The huge majority, a full 75%, comes from the day-to-day costs of just keeping the lights on. So when we slice up those operating costs, one thing just jumps right off the page: energy. It is the single biggest piece of the pie, accounting for a whopping 40 to 60% of all running costs. So the real challenge in making clean water affordable isn't the machine itself, it's the insane amount of energy you need to power it. Okay, but this is where the story takes a really cool turn. We've just pinpointed this massive energy problem. But what if the perfect solution was hiding in plain sight, perfectly lined up with the problem, just waiting for us? And right here, this is the big aha moment. Seriously, look at this. On the left, you see a map of all the places with the least access to safe drinking water. On the right, a map of where the sun shines the strongest. You see the overlap? The areas with the greatest need are often the exact same places that are just drenched in sunlight. The takeaway here is so simple, but it's so powerful. We don't need to build massive power lines and transport energy from thousands of miles away. The clean, abundant power source we need to solve the water crisis, it's already there, shining right down on the people who need it most. So this is a brilliant idea in theory, but does it actually work in the real world? Let's go back to that case study from Lesotho and see how they put this idea to the test. So this is the system they designed. It's a hybrid setup. It uses solar panels to create electricity, and that electricity then powers a reverse osmosis system. Basically, reverse osmosis just uses really high pressure to push salt water through a super fine filter. All the salt and gunk get trapped, and only pure, clean water gets through. It's a direct, self-powered solution. But here's the million-dollar question. Does it make financial sense? Well, the data here is pretty incredible. They compare two different systems. A smaller one produced water that cost about $1.25 per cubic meter. But when they scaled it up to a larger system, the cost just plummeted to 75 cents. So the bottom line is that this isn't just some cool science experiment. It's a practical, economically viable solution. And this is the crucial part. It actually gets cheaper the bigger you build it. That's economies of scale in action, and it means the water becomes more affordable for everyone. So, Let's zoom out. What does all of this mean for the future of water? We've seen how you can pair a huge problem with a local resource to unlock a really powerful solution. Let's just wrap up the key ingredients for making this work. The research really boils it down to 4 key things. First, you've got to use hybrid energy, with solar leading the charge. Second, you build an energy recovery systems that basically recycle energy inside the process, and that can cut consumption by up to half. Third, you use a modular design so you can scale it up easily. And finally, you optimize the water pretreatment to keep the whole system running smoothly for a long, long time. You know, when you step back, the biggest lesson here isn't really about some fancy new machine. It's about smart, thoughtful design. It's about connecting the technology to the local environment, the local resources, and the real needs of a community. It's about working with nature, not trying to fight against it. And that really leaves us with one final thought to chew on. We just walked through a system that takes 2 of the most basic things on our planet, sunlight and saltwater, and turns them into the very foundation of life. So it makes you wonder, what other problems that seem impossible today are just one clever connection away from being solved?